Hang on, because we're about to screech to a halt. That's right, the Earth is going to stop spinning for 5 seconds. How much damage would this sudden stop cause? What would you experience in different parts of the world? And when the Earth starts spinning again, would it still be habitable? This is What If, and here's what would happen if the Earth stopped spinning for 5 seconds. The Earth makes one full rotation on its axis in one day. This gives us day and night. The Earth is spinning because of collisions that happened when the planet was forming 4.6 billion years ago. As a huge disk of gas and dust swirled around the sun, dust and rock grains clumped together, generating forces that kept the planet rotating in one direction. You could imagine it much like a figure skater spinning faster and faster. And with almost no forces in space to slow the planet down, we keep rotating, and will continue to for billions of years. But if the Earth stopped on a dime, would you fly right off the surface? If the planet came to an abrupt halt, the atmosphere would still be in motion. That means, though everything has lurched to a stop, powerful winds would continue to blow. And these wouldn't be a strong breeze. They would be many times stronger than any storm you've ever encountered. Now, the strength of these winds would differ based on where you were on the planet. At or near the equator, the Earth is rotating the fastest. Here, you'd experience wind speeds of 1,670 kilometers per hour. Those winds would knock you off your feet. But forget about you. These winds would be strong enough to tear up the Earth's crust. So it wouldn't matter if you were out in an open field or inside a steel-reinforced building. These winds would obliterate you. For context, the strongest F5 tornadoes have velocities up to 511 kilometers per hour. And these storms can move houses off their foundations, send cars flying, and even tear apart concrete structures. The winds from the Earth's emergency brake would be 3 times stronger than that. So if the crust under your feet didn't crumble, you and a lot of other stuff would likely go flying a great distance. But not off the face of the Earth. The escape velocity, or the speed you need to escape the Earth's gravitational forces and enter space, is about 40,000 kilometers per hour. In other parts of the world, like New Zealand or France, you'd experience slightly weaker winds, but at 1,180 kilometers per hour, these would still be much stronger than any storm ever. These winds would pretty much destroy everything, but they wouldn't be the only hazard you'd need to keep an eye out for in these short 5 seconds. Our planet is not a perfect sphere. It bulges near the equator due to the centrifugal forces generated by the planet's rotation. If the rotation stopped, the Earth would transform quickly into a perfect sphere. All the water gathering near the equator would flow away toward the poles, generating a massive tsunami. 5 seconds later, when the planet returned to its full-speed rotation, that water would backtrack. A wall of water would slam into everything and everyone, twice. That's one heck of a storm. Maybe the only place you'd be safe in this scenario is near the North or South Poles. Here, the wind would be the mildest. Now, you must be relieved to hear that the Earth has returned to its normal rotation after all this, but like I said, there would be nothing left on it. Every building, all farmland and all technology would be demolished beyond recognition. Billions of people, if not every single person on Earth, would die from the brute force of being slammed by the massive gusts of wind. So, if you're looking to survive this apocalyptic scenario, you'd better start building an underground bunker. Luckily, it's expected the Earth won't come to a halt anytime in the next few billion years. Trees are falling, ecosystems are collapsing, and our infrastructure is crumbling. Crops are failing, and water is scarce. Earth is becoming a dead planet. On the plus side, there's never been a better time to buy property. But who can think about real estate when they can't leave their own home, let alone get out of bed, let alone breathe? This is What If, and here's what would happen if the Earth was as big as the Sun. Everyone knows the Sun is big. I mean, look at it. And that's just how big it looks from about 150 million kilometers away. Just imagine what it would look like if you were standing next to it. Never mind. The Sun accounts for 98% of the mass of our entire solar system. And compared to the densest planet, which is our very own planet Earth, the Sun is more than 1,000,000 times more massive. In fact, it would take roughly 1,300,000 planet Earths to fill the entire Sun. But what if it only took one? Earth would be a very different place if it were the same size as the Sun. Just imagine our whole planet's topography being stretched out. Continents would expand, providing much-needed relief in places where overpopulation inhibits the quality of life. And owning a nice plot of land might actually be more affordable than it is on today's planet Earth. But now we'd also have to consider that every body of water on our planet would have more area to cover. This means that lakes, rivers, and even the oceans would be shallower, making them more susceptible to evaporation and potentially drying out. Marine life would undoubtedly suffer since shallower water would gain more heat from the sun, jeopardizing sea creatures that need colder water to survive. With other smaller water sources beginning to dry up, wildlife on land might have to relocate or travel much farther for fresh water, which would also put them at risk. Us humans would be in an equally precarious position. Not only would we probably start fighting over the limited fresh water that's available, our food crop yields would also start shrinking. Food crops need a certain amount of soil to grow in and to absorb the nutrients they need. If our world was as big as the sun, then, like the water, our soil would have to be spread out to cover a much larger space. Less soil would mean less food, while the demand for food would stay the same. There's also another issue that we haven't considered, which, when we factor it in, makes life on Earth pretty much impossible. Earth being the same size as the sun is hard enough to imagine, but when you consider a sun-sized Earth having the same mass as the sun, it doesn't only jeopardize our survival, it disrupts our entire solar system. Think about it. With the Earth as big as the sun, you'd pretty much lose the moon either way. But if a planet has more mass, it will also have a stronger gravitational pull. In this case, gravity on Earth would be 28 times as strong as it is now. We'll get to how this affects you in a moment, but first, let's look at the bigger picture. The reason why our solar system moves the way it does now is because the sun's mass is so great. Its gravitational pull forces other planets into its orbit. The sun currently has 98% of the mass in our entire solar system, but now the sun and the Earth would each have 49% of the mass in our solar system. Would this result in some sort of binary system in which the sun and the Earth orbited each other? How would this new rivalry affect the orbits of the other planets in our solar system? And would a significantly higher gravitational pull mean that Earth would get hit by a lot more asteroids? Well, there'd be a lot more to worry about than just asteroids. Our satellites would also probably crash down to Earth, while buildings and bridges would crumble and collapse under the increased gravitational pressure. Only thick trees that were low to the ground would remain standing, but it's unlikely that much else could shoulder the added weight. You would be significantly heavier, and you probably wouldn't be able to walk anywhere. Think about it. If you weigh 50 kilograms on Earth right now, it would feel like you weighed 1,400 kilograms on a sun-sized Earth. The cruel twist is that as gravity increases, time would slow down. So you might be able to live longer, but it would probably be a long life spent lying in bed with aches and pains. Luckily, we can wake up from this nightmare because the Earth will never be as big as the Sun. In fact, our planet is actually getting smaller. Our atmosphere leaks, and so we end up losing several hundred tons of mass to space every day. So take a nice deep breath and be glad it's that easy. It's not always a good idea to mess with proportions, and bigger definitely doesn't always mean better. See that strip of stars splashed across the night sky? That's our home galaxy, the Milky Way. You can see it from Earth because we live right on the outskirts, far away from all the fun stuff happening at its center. What would it be like to reside in its galactic downtown? What would our night sky look like? Would we get sucked into a black hole? This is What If, and here's what would happen if the Earth was near the center of the Milky Way. The Milky Way is huge, about 100,000 light years across. It has 4 large spiral arms encircling its center. That makes it a barred spiral galaxy, just like most galaxies in the observable universe. If the Earth packed up its belongings and moved to the heart of the Milky Way, things would be looking pretty bleak for the survival of any kind of life on the planet. But not because of the Milky Way's supermassive black hole. The Earth is located in a quiet neighborhood in one of the smallest spurs of the Milky Way, the Orion Arm. We've got approximately 27,000 light years between us and the galactic center. It's a comfortable spot to live in. The temperatures on Earth are just right to sustain life, and there aren't too many space hazards that could wipe out our existence. Well, I didn't say it's completely safe, did I? Living anywhere near the center of the Milky Way would be different. It would depend on what part of that center the Earth had the misfortune to occupy. The closer you get to the heart of the galaxy, the tighter the stars are packed together. Because of this high star density, the Earth would be blasted with a lot more radiation than what the Sun throws at you right now. Under these circumstances, the odds of life ever evolving would be pretty small. But if the Earth moved to the center, together with all its inhabitants, you'd find yourself very unlucky. Earth's magnetosphere wouldn't be able to protect you from space radiation blasting from all directions. This could change the Earth's climate and cause everything on the planet to either mutate or die. If you lived, your biggest concern would be a close encounter with a supernova. A supernova occurs when a massive star collapses, releasing radio waves, X-rays, cosmic rays, and gamma rays into space. For all we know, one massive stellar body could throw the Earth out of the Sun's orbit. Our planet would be surrounded by foreign stars until one of them exploded in a supernova and wiped us out for good. But it would look spectacular from Earth, if only for a brief moment. There's another big hazard that lies within the Milky Way's center, a supermassive black hole called Sagittarius A star. If getting sucked into a black hole isn't on your to-do list, consider yourself lucky. The Earth might stay far enough from it that we wouldn't get engulfed by this cosmic beast. At a distance of 20 billion kilometers from the black hole's event horizon, the Earth could develop a speed of 25 million kilometers per hour. That's over 230 times faster than the speed our planet is moving at right now. So, would that mean strong winds? More natural disasters? Would you end up flying off into space and right into the black hole? It sure wouldn't be good for you, or anything else on the Earth's surface. The Earth is perfectly designed to be right where it is. It can survive on the outskirts of the galaxy, but you wouldn't want it to be anywhere else. The most dangerous place for a planet to be located is anywhere near the center of a galaxy, any galaxy. If you just want a nice view, your best bet might be to teleport the Earth to the middle of a nebula instead.
The sky is falling!
Get a grip! The sky isn't falling. It's getting sucked into outer space. And so are all the oceans, and the trees, and cars, and roads, and bridges, and the Earth's core, and you. So get a grip, and hold on tight.
Hang on, kid!
You're in for a wild ride. This is What If, and here's what would happen if we lost gravity for 5 seconds. Unless you're an astronaut, you probably don't spend a lot of time thinking about gravity. We all take gravity for granted, and it would be hard not to. Aside from a tiny sliver of the world's population, most humans don't know a life without gravity. From the universe to our solar system to each planet, all the way down to our own bodies, gravity holds everything together. But since we tend to see gravity as a given, it's hard to imagine just how helpless we would be without it. Until it's actually gone. Gravity is an attractive force between any two masses. The greater the mass, the greater the gravity. The greater the gravity, the stronger the pull. Gravity is the reason why Earth rotates around the sun, why we experience high and low tide, and why we can walk on this planet without floating away. Most importantly though, gravity secures our atmosphere, holding in the air we need to breathe. In fact, there are a lot of things we can thank gravity for. So many though that if we tried to list them all here, we'd probably end up with a video longer than Titanic. So just to give you an idea of how important gravity is in a really short amount of time, we're going to take it away from you. But not for too long. Just 5 seconds. Are you ready? With the world still spinning at its usual 1,600 km/h speed, everything that isn't secured firmly to the ground would go flying. Cars, boats, trains, planes. Well, obviously, but not like they normally do. More like this. The Earth spins faster along the equator, so the impact of zero gravity would be felt hardest there. At the equator, you could experience winds almost 6 times stronger than the ones produced by Hurricane Katrina. That means that in just 5 seconds, you could be blown as far as 2.3 kilometers in any direction. And not just you, there will be plenty of people, objects, and animals to look out for. Not to mention trees, soil, and mid-air floods from the world's ponds, lakes, rivers, and oceans. At the same time, the gases in the atmosphere would drift out into space. Not only are we now losing huge amounts of oxygen, but the sudden and sharp drop in air pressure would instantly shatter everyone's inner ears. And then there's the planet itself, which is literally held together by gravity. Without gravity, the pressure of the Earth's inner core would cause the planet to expand. It's not like 5 seconds without gravity would cause the world to explode, but even a 5-second expansion of the Earth's inner core would cause some major earthquakes and trigger huge volcanic eruptions. Add one more item to your list of dangerous things flying through the sky: lava. Out in space, the planets in our solar system that normally orbit the sun would instead start drifting away from it. Earth would follow its neighbors at a speed of 30 kilometers per second. In just 5 seconds, it would have traveled 150 kilometers. That's not far enough for our planet to be out of the habitable zone, but how habitable would Earth be after 5 deadly seconds without gravity? When gravity was restored, you'd hit the ground hard. If the impact didn't kill you, or if you weren't crushed by a heavy object, you would still be severely injured.
My back! Oh, my back!
Hopefully, you'd catch your breath in time, with gravity pulling oxygen back down to Earth and bringing the atmosphere back around the planet. But there would still be earthquakes and volcanic eruptions as the Earth's core becomes compressed again. And there would still be massive flooding due to the significant displacement of the oceans. The number of casualties would be astronomical, not just from flying debris, lack of oxygen, or simultaneous natural disasters, but because in those 5 seconds without gravity, the Earth's crust literally opened up and swallowed several major cities. So yeah, a lot can happen in just 5 seconds, and that just goes to show how essential gravity is to life on Earth and beyond. You may think you're special, and you most certainly are, but just remember that you're part of something bigger than you, and that's what keeps you grounded. On our hypothetical journey, we've already tested out living on a flat Earth, a cubical Earth, even a hollow Earth. So, what do you say we try to survive on an Earth with a giant hole in the middle? Would a planet like this even have a chance of being habitable? Would it still have the moon? How would gravity work? And what would the view be like on an Earth like this? This is What If, and here's what would happen if the Earth was shaped like a donut. Hey, planetarily speaking, size matters. And so does shape. This is what mathematicians would call a toroidal world, or a torus planet. To me, it's an Earth shaped like a sweet, fried, ring-shaped pastry. Whatever you call this Earth, theoretically, it's not impossible. Planets don't naturally form in the shape of a donut, but the laws of physics do allow for such worlds to exist. It just wouldn't be Earth as you know it. Okay, I'm just messing with you here. It wouldn't kill anyone to evolve on a donut-shaped Earth, unless it had a shape more like a hula hoop. Having a center that's so much larger than the physically solid portion of Earth would result in some very unstable conditions. See what I mean? Disastrous. So let's focus on a planet that looks like a traditional donut and closely mimics our own Earth. This donut-shaped Earth would have a similar position relative to the Sun and the same axial tilt. It would even have a similar escape velocity, 11.4 kilometers per second for most of the planet. At the donut's equator, the escape velocity would go down to just 6.5 kilometers per second. So, if you were going to send rockets into space, that would be the best place to break free of the gravitational clutches of a donut-shaped Earth. Speaking of gravity, depending where you were on a torus Earth, you'd weigh up to 3 times less than you usually do. If our round Earth has a surface gravity of 1 g, the surface gravity of a donut Earth along the poles would be 0.65 g. And at the equator, the gravity would go down to just 0.3 g. It would be like walking on the surface of Mars. Even though the donut-shaped Earth's gravity would be lower than what you're used to, it would still be constantly trying to collapse the planet in on itself. To fight the urge to become a sphere-shaped Earth, a donut Earth would have to spin much faster than our round Earth does. That way, centrifugal forces would kick in and keep the donut hole intact. But because of this quick rotation, a day on Earth would only last 2 hours and 50 minutes. Or, if you prefer to stick to a traditional 24-hour day, you'd be dealing with at least 8 sunrises and sunsets every day. You'd have to adapt to working day and night and sleeping through hours of daylight. But it would be much worse than that for the animals that are synced to the patterns of the moon and the sun to breed, migrate, and hunt. Oh, and by the way, what would happen to the moon? Well, the good news is we'd still have it. Most likely, it would be pulled towards the middle of the hole and bob up and down in the middle of the planet. Or it could be affected by the gravity of the donut's outer edges and create a figure-8 orbit around the Earth. The bad news is either of these orbits would affect the tides on Earth and wreak a little havoc. Oceans could have such unstable water levels that having coastal cities might not be a thing. The overall climate on a donut Earth would be similar to what we currently have on our round Earth. It would be colder in the polar regions and warmer at the equator, but the weather would be a little more extreme and could even make some parts of the planet inhospitable due to storms and hurricanes. It's hard to predict where the countries would be located on a tourist planet, but as far as topography goes, most likely the donut hole would be lined with mountains, and they could be substantially larger than anything we have on Earth right now. If you wanted to live on the inner edge of a donut-shaped Earth, you'd be enjoying this view. Unlike in some what-if scenarios, life wouldn't come to an end in this one. Humans of a donut Earth might never cross the ocean. They'd evolve separately on different continents. But at least there would be no mass extinction, and no areas of the planet would become too extreme for us to survive. Donut Earthers might or might not have the tools and tech we have today. They might not even stumble onto the concept of a donut in the first place. Jupiter, Uranus, Saturn, Earth? Sadly, the Earth didn't make it onto the list of the solar system's ringed planets. If it did, would it still be able to host life? This is What If, and here's what would happen if the Earth had rings like Saturn. When the Earth was young, it most likely had a ring of rock debris around it. 4.5 billion years ago, another planet, Theia, hit the Earth. The giant impact sent a ring of matter hurtling into the Earth's orbit, but it didn't stay like that for long. The rocky debris soon formed another celestial body, the one we now call the Moon. Having planetary rings visible in the sky would look way more spectacular than just one gray rock, right? Maybe, but if our planet got beautiful rings like these tomorrow, much of life on Earth might not survive the renovation process. It wouldn't necessarily take another collision to form rings around the Earth. We could just crumble the Moon, and for that, we'd only need to move it a little closer. The gravitational pull that our planet exerts on the Moon isn't equal everywhere. It's much stronger on the side of the Moon that is closest to us. There is a limit on how close celestial bodies can be to each other. It's called the Roche limit. If they get any closer than that limit, the larger body shreds the smaller one into pieces. The distance of the Roche limit depends on the size, mass, and density of the two objects. For instance, the Sun rips up comets that come within 1.3 million kilometers of it. The Earth will tear apart an average-sized comet from approximately 18,000 kilometers away. For the Moon, the Roche limit would be about 9,500 kilometers. The rings we might get from something the size of the Moon would be about 5,000 kilometers wide and around 9.5 kilometers thick. But unlike Saturn's icy rings, ours would be made of nothing but rock. The Earth is just too close to the Sun to keep the debris iced. Looking out at the sky, you'd be able to see these rings from Earth at all times. Because of the brightness of the rings, the Moon wouldn't seem as bright anymore. That is, if we still had the Moon. If the Moon crumbled up and became our rings, well, there'd be nothing else up there to look at. And there would be some other consequences. The rings suddenly hugging Earth would disrupt internal navigation systems of some animals. If not enough direct sunlight was making it through the rings, they would also affect photosynthesis and our oxygen supply. In the shadow of the rings with no contact from the sun's rays, the temperature would get so cold that it would make the shadowed areas of the Earth almost uninhabitable. Communications satellites, generally placed around the Earth's equator, would find themselves right in the middle of a rock storm. We'd need to find another way to keep the internet alive if we want to keep posting selfies on a ringed Earth. We'd be better off in a scenario where the Earth has always been like this. Provided we didn't lose sunlight and oxygen, we'd evolve just fine. But we'd have to develop other means of communication since we wouldn't be able to send satellites into an orbit full of rocks. Space would never become our final frontier. The rocky rings around the planet would be a sort of orbital barbed wire fence, keeping us all grounded. And just like the rings of Saturn, Earth's rings wouldn't last forever. One day, they'd start to feel their age and drop from the sky. Make sure to wear a helmet, and don't forget to look up and enjoy the show. Do you find the time it takes Earth to spin around each day a little slow? Well then, how about we speed things up? A lot. What would happen to the length of our day? What geographical and climate-related changes would occur? And at what point would life on Earth cease to exist? This is What If, and here's what would happen if the Earth was spinning at the speed of light. The Earth makes one full rotation on its axis every 23 hours, 56 minutes, and 4.1 seconds. And it's not moving at the same speed everywhere. The rotational speed varies depending on your distance to the poles. If you're at the equator, it moves the fastest at a rate of 460 meters per second. At the North or South Pole, it's moving the slowest. Technically, it's not moving at all. This rotation makes Earth suitable for life. The diurnal cycle, or the shifting between day and night, helps keep the planet at a habitable temperature. Earth's rotation is the driving force of weather patterns. Even tides are affected by the Earth's spin. So, if we were to accelerate this rotation, would we completely destabilize the climate? If you increased the rotational speed by 0.45 meters per second, our days would be shorter, but only by a minute and a half. You might not even notice the change.
I don't know.
But even with this slight increase, sea levels would rise by several centimeters, or a few inches. Yeah, the water around the poles would migrate toward the equator. Now, if you increased this acceleration to 45 meters per second, then a single day would be about 22 hours. You'd start to feel confused, almost like jet lag. We'd also need to add a few more days to the year. But for sea levels, it would be a dramatic change. The world's oceans at the equator would rise as much as 9 to 20 meters. Places like New York, Venice, and Mumbai would be submerged. Millions of people would be displaced. Now, if we doubled the current rotation speed to 920 meters per second, disaster would strike. Water would cover everything except for the highest mountains like Kilimanjaro or the highest summits of the Andes. Satellites orbiting the planet would be out of sync as they need to orbit at a speed that matches our rotation. This would disrupt communications, television broadcasting, and military operations. And you would notice some significant weather changes. The air would be heavy with moisture. Dense fog, clouds, and constant rain would be the norm in regions near the equator. If you keep speeding things up, at some point you could fly off the planet. That's because the centrifugal force of the rotation would be enough to overcome the gravity keeping you on the surface. This would happen at a speed of 7,886 meters per second. And you would experience reverse rain. Yeah, droplets of water would move upward in the atmosphere instead of falling. Now, if you pushed the speed to 11,000 meters per second, the Earth's crust would begin to flatten at the poles and bulge around the equator. Enormous earthquakes would rattle the planet. There would be little chance that anything on Earth could survive. But if you were to crank the velocity up some more,
brace yourself,
like to the speed of light, things would get wild. If the Earth rotated at a speed of 299,792 kilometers per second, that would be 652,000 times faster than today. The dimensions of the planet would change. Once a sphere, the Earth would contract into a thin disc-like shape, and so would you, along with every other object. You could finally say the Earth is flat.
The Earth is flat and stationary.
Rotating at this extreme speed would distort time on Earth. It would slow down so much that it would eventually stop. You would freeze in time, so hopefully you'd be caught in a good moment. Earth could become a tiny black hole. That's because an object moving at the speed of light has an infinite mass. Yeah, nothing would be making it out of this situation alive. Maybe we'd stand a better chance if Earth started spinning in the opposite direction. There are hundreds of billions of alien worlds in the Milky Way galaxy. And scientists have already discovered and confirmed over 5,000 of them. They call these worlds exoplanets. Some of them are really small, like Kepler 37b. This tiny planet is even smaller than Mercury, the smallest planet in our solar system. Kepler 37 is just slightly larger than our own moon. It could easily replace our cosmic companion in the night sky. Only it's pretty far from us. This tiny space rock is located 208 light years from Earth, where it orbits a star that's a bit smaller and cooler than our sun. Small rocky worlds like Kepler 37b are a pretty rare find. Because they're so tiny, they're more difficult to spot, but scientists have still managed to confirm about 200 of these worlds. Most of them are many, many times closer to their stars than our planet is to the Sun, and Kepler 62c is no exception. This Mars-sized exoplanet orbits its star roughly 4 times closer than Mercury orbits our Sun. It only takes a little over 12 Earth days to make a full orbit. Kepler 62c must be scorching hot and extremely volcanic. Definitely not the kind of place you'd want to visit. And neither is this exoplanet, KOI 55b. Scientists think this planet used to be the size of Jupiter, but then its sun exploded into a red giant and swallowed the planet whole. No surprise there, KOI 55b is incredibly close to its star. So close that it takes this hellish world less than 5 hours to make one orbit. And KOI 55b is evaporating so much that it will soon disappear from its planetary system. It's not alone. Many of these planets have their atmospheres torn away by their host stars. Some 41 light years from Earth, there's a super-Earth that used to be a mini Neptune. GJ 1132b might have had a thick hydrogen atmosphere in the past, but its young hot star stripped it away, leaving only a rocky core behind. When its star stripped away its original atmosphere, some of the gases were absorbed into the planet's mantle, and now, through this planet's volcanism, they're released back. GJ 1132b could have become a potentially habitable world, but it's 26 times closer to its star than Mercury is to the Sun. No chances for life on this super-Earth. But life might be possible on these slightly larger super-Earths. Scientists have found many of these worlds orbiting in their sun-like stars' habitable zones. And that's good news. Now, we'd have to go and explore more of these planets up close to find out what their atmospheres are like. This one seems intriguing. Kepler 452b is 1.6 times the size of Earth, and it's about 6 billion years old. Earth is a youngster compared to this world. Our planet is only 4.5 billion years old. Okay, now I know this is your favorite exoplanet, Kepler 22b. And I like it too. This super-Earth might be covered in a super-ocean. It sits comfortably in its star's habitable zone and has a huge potential for life. The only problem is that it's big. Kepler 22b is 2.4 times larger than Earth and about 9 times more massive. If Kepler 22b was the size of Earth, it would have an average surface temperature of about 16 degrees Celsius. But because it's a lot bigger than Earth, it could be a rocky planet, a water world, or even a gaseous planet like Neptune. And speaking of gaseous planets, at this size, exoplanets stop being super-Earths and become gas giants. More than half of all exoplanets we've discovered are either Neptune-like ice giants or gas giants like Jupiter. Many of them orbit a little too close to their host stars, and they pay a high price for that proximity. For one, they're incredibly hot, and sometimes their host star rips their atmosphere away. Kinda like what GJ 1132b went through. But among them, there are some cold planets too. Oof! This is Kepler 16b. It's not quite as large as Jupiter, but the cool thing about it is that it orbits not one, but 2 stars. Only you wouldn't be able to see those stars because you wouldn't be able to stand on its surface. You see, Kepler 16b is a Saturn-sized gas giant. It might have some rocky elements inside it, but its 2 host stars are much cooler than our Sun, making Kepler 16b a frigid, lifeless world. Speaking of lifeless worlds, well, that might be what Earth becomes if we don't work to stop climate change. You've seen the hundreds of wildfires spreading across Canada. Well, this is due to climate change making the world hotter and drier. This toxic air made its way to New York, Toronto, Detroit, and Chicago, resulting in some of the worst air quality in the world. California is trying to prevent wildfires by purposefully burning thousands of acres a year. This is in order to reduce vegetation that could fuel a catastrophic wildfire. And this is just one example of what we need to do to help with climate change. Check to see what your local and federal governments are doing to help, because we only have one Earth and we don't want it to turn into one of these uninhabitable exoplanets. Okay, now on to the worlds that are bigger than Jupiter. This delicious exoplanet has the density of a marshmallow. TOI 3757b is slightly larger than Jupiter, but it's not nearly as massive. But there are always bigger and badder planets out there, like Kepler 7b. This one is interesting. Kepler 7b is larger than Jupiter, but it has half of Jupiter's mass. This means the planet is like a super light cloud, a scorching hot super light cloud. Kepler 7b is a hot Jupiter planet. It's 12 times hotter than the king of the solar system. Still, Kepler 7b is not the hottest or the weirdest of the exoplanets. Some of these gas giants are so unimaginably hot that they tear molecules apart. Yeah, and some planets are just doomed. 1,400 light years away from Earth, a star slightly bigger and hotter than our Sun is devouring its planet. This planet is called WASP-12b. It's almost double the size of Jupiter, but it's not going to last very long as far as planetary lives go. WASP-12b is so close to its star that it takes just over 1 Earth day to complete its orbit. Its own star is actually eating the planet's atmosphere, making it stretch into the shape of this egg. 10 million years from now, WASP-12b will be gone. And some exoplanets are unimaginably huge. The biggest one of them is almost 7 times larger than Jupiter. HD 100546b isn't just 7 times larger than Jupiter, it's also 750 times more massive. HD orbits its star 10 times further away than Jupiter orbits the Sun. That's pretty far, and it makes scientists wonder how this gigantic exoplanet formed so far away from its star. There's no doubt that some exoplanets out there look promising for finding life. We've found quite a lot of them orbiting in the habitable zone of their stars. In fact, some of these worlds might even be better for life than Earth. 5 billion years from now, the Sun will expand and become a red giant. And the Earth might just be in the way. If humans were still around then, would we leave the Earth? Or would we move it? This is What If. And here's what would happen if we moved the Earth. What's the Sun's problem anyway? Well, like any other star, it has an expiration date. The beginning of its end will feature our Sun swelling into a red giant, wiping out everything that happens to be orbiting it too closely, like the Earth. If we wanted to survive, we'd need to take action long before the Sun started going on a rampage. It would take 1 billion space shuttles to evacuate about 7.5 billion Earthlings. Even if we could launch 1,000 space shuttles every day, it would take over 2,700 years to move everyone off the doomed planet. Maybe we could save ourselves some trouble by moving our whole planet instead. That's actually quite possible. We'd only need to give the Earth one big boost in the right direction and keep it on course. And there are a few ways to do that. To move the planet out of danger, we'd have to change its velocity by 1,200 meters per second. That would require about 7,000 of the most powerful rockets ever built, but this plan has one big flaw. To escape the Sun's expanding flames, we'd need to escape pretty far. At least move into the orbit of Mars. Moving something as bulky as the Earth to a safe zone there might take us billions of years. And for every billion years that passed, we'd use up about 1/3 of the Earth's mass as propellant. That's not very efficient, is it? To move the Earth more efficiently, we'd have to consider electric propulsion. Unlike the chemical one used in most rockets, electric propulsion doesn't require a lot of mass. We could get away with sacrificing only 2% of the Earth's mass every billion years. You'd hardly notice the difference. But this option would require a lot of power, about 800 times more than what's produced here on Earth right now. Plus, it would take some careful engineering to make this work. Because the Earth is spinning, a rocket placed in one location would not always point in the right direction. We'd need to place rockets all around the Earth and have each of them fire only for a certain amount of time. That would keep the Earth on course. It would take 1 billion years to move the planet out of the danger zone. Any miscalculation could mean extinction. There is a better way, and it involves asteroids. Aerospace engineers use something called a gravitational slingshot to alter a spacecraft's path without using too much propellant. When a spacecraft approaches the Earth and then leaves its gravitational pull, it receives some of the Earth's orbital energy. We could use the same effect to redirect our planet. First, we'd have to make comets or asteroids pass close to the Earth, transferring some of their energy in the process. Next, engineers would redirect the asteroids close to Jupiter and Saturn, where they would pick up some of the gas giants' energy. From there, the asteroids would bring that energy back to Earth. We'd repeat the process over and over again until it got us to a safe orbit. Of course, that would be quite dangerous too. The slightest miscount might redirect a gigantic asteroid right into the planet and destroy all life as we know it. Now, we wouldn't be taking the moon on our road trip around the solar system. Most likely, we'd ditch our celestial partner the moment we pushed Earth's orbit away from the Sun. Now, the big risk here is that moving the Earth might disrupt the whole planetary system. It could easily destabilize Mercury or Venus, setting them on the path of destruction. And there's no one living on those planets that can save them. At least not that we know about. Since its formation, the Earth has been revolving west to east on its axis. If one day our planet started rotating in the opposite direction, it would no longer be the Earth as we know it. In what ways would a clockwise rotation change the Earth? And why would you end up living in a desert? This is What If, and here's what would happen if the Earth started spinning backwards. You don't notice it, but our planet spins pretty fast, 460 meters per second as measured at the equator. A sudden change of direction would cause disastrous winds and massive waves. Together, these abnormal weather conditions would wipe out nearly everything above the ground. Let's just skip over this destroying transition. Imagine our planet reversed its direction billions of years ago. You'd see the sun and the moon rise in the west and set in the east. And you'd never believe that the Sahara could be a desert. How different would our planet turn out to be? Short answer, the reversed spin would make Earth much greener. Long answer, this new rotation would change winds and ocean currents, and that would shift the planet's climate entirely. Oceans work as a global climate control, distributing the sun's heat all over the Earth. They divert moisture from the driest, hottest badlands and carry rainfall to thorny jungles. If the Earth reversed its rotation, one very important climate-driving current would disappear from the Atlantic Ocean. Instead, a different current would surface in the Pacific and become responsible for distributing heat around the globe. This new current would make the deserts retreat from Africa and Eurasia. You'd have to go to the other side of the planet to do some quad biking on the Golden Landscape. More specifically, to Brazil. The US would also get very arid in the south. But none of the new barrens would be anywhere close to how dry the Sahara Desert is now. There'd be much more vegetation covering the planet. Hey, that's more oxygen for all of us. But those living in Western Europe would be in for a shock. The Pacific Current would push a lot of cold water that way, bringing freezing winters to the region. Russia, on the other hand, would warm up and take a break from being the coldest country on Earth. Life on the reverse spinning Earth would be different too. In the oceans, cyanobacteria would dominate over other phytoplankton species. Billions of years ago, the oxygen-pumping cyanobacteria invented photosynthesis and transformed our planet's atmosphere. Maybe having so much more cyanobacteria on Earth would alter the atmosphere even further, filling it up with too much oxygen for us to even exist. Let's just leave the planet to spin the way it does. In the past few billion years, Earth has been pummeled by asteroids, crashed into other planets, and frozen over several times. Not to mention being ruled by all kinds of crazy life forms. Sometimes it's a wonder that our blue homeworld has survived it all. But if we want to take a whirlwind tour of our planet's history, we'll have to start way back at the very beginning. Some 4.5 billion years ago, our solar system began to emerge out of a dense cloud of interstellar gas and dust. This cloud collapsed into a swirling disk of matter that got hotter and hotter and hotter until hydrogen fused into helium. And just like that, our sun was born. And baby Earth was on its way too. After the birth of our star, all the matter on the farthest ends of the spinning disk began to clump together. These clumps would be the seedlings for the planets and moons in our solar system. As they accumulated more matter, they grew bigger and more spherical. The clumps in the cooler regions of the solar system were mostly made of ice, liquids, and gases. Closer to the sun, all the rocky material formed the inner planets like Mars and Earth. This young Earth was incredibly active, volcanically speaking. It spewed out gases like hydrogen sulfide, methane, and carbon dioxide. These gases made up the very first atmosphere on our planet. Early Earth was constantly bombarded by large asteroids and comets, and soon Earth experienced an even more violent collision. Theia, a planet the size of Mars, slammed right into our young world. This epic collision threw chunks of matter all around Earth's orbit, and then gravity bound them together into what we know now as the Moon. On this hot, early Earth, there were no oceans. All water existed as gas. But 3.8 billion years ago, our planet cooled enough for water to condensate and become liquid. The very first primitive ocean covered this young Earth and turned it into a water world. H2O is an essential ingredient for creating living things, so with all that water, life appeared on Earth about 3.7 billion years ago. These earliest forms of life were microscopic organisms, but it was nearly a billion years after that that some of these organisms changed the course of the world. Earth didn't stay as a water world very long. Soon, the very first continents emerged from the ancient ocean. Scientists call them cratons. As more and more land rose from the ocean, the very first supercontinent appeared on the planet. Valbara wasn't exactly a supercontinent. It was pretty small. Scientists think it was smaller than the continent of Australia. Around 2.4 billion years ago, cyanobacteria evolved to become our planet's first photosynthesizers. Finally, we had some oxygen producers to make Earth's atmosphere much more hospitable. And the rest is history, folks. Just kidding, we've still got a long way to go. With all this new oxygen, Earth's atmosphere had much lower levels of carbon dioxide. And that made the planet icy cold. Much of our young world froze over as Earth saw its first ice age. Now, as Earth's atmosphere was changing, the continents were moving too. They broke up and reassembled into the next supercontinent, Rodinia. Rodinia was a real supercontinent. It may have been the largest supercontinent to ever cover the planet. And life? Well, life finally became more complex. But then something happened. Rodinia broke apart and a new supercontinent assembled. This one was called Pannotia. Then, between about 540 and 485 million years ago, there was an explosion of new life. This time was called the Cambrian explosion, and the animals that evolved during this period had hard body parts, like shells or spines. The most famous of all were the alien-looking trilobites. Around 440 million years ago, the climate suddenly shifted and the temperature of the ocean changed dramatically. Earth saw its first mass extinction event. This was the Ordovician Silurian extinction, and a majority of the life that had been spreading around the planet vanished. Many of these life forms laid the foundation for the ecosystems that we have on Earth today. Somewhere between 420 to 350 million years ago, the first trees arose from Earth's soil. And the first animals made their way to land, too. 250 million years ago, the planet was covered by our last vast supercontinent, Pangaea. Sadly, it was also during this period that Earth witnessed the greatest mass extinction event in our history, the Great Dying. Huge amounts of greenhouse gases and accelerated global warming wiped out about 90% of all species on Earth. But this mass extinction helped pave the way for the next wave of animals to evolve. 240 to 230 million years ago, the first dinosaurs appeared. For the next 150 million years, they'd rule the land. If you were there, you'd have witnessed the gigantic sauropod Argentinosaurus, the largest land animal ever. Or you might have been chased by one of the Earth's greatest apex predators, the T-Rex. And you'd also witnessed Pangea breaking up and forming the continents we know today. Okay, you may already know where this is headed. 66 million years ago, an asteroid slammed into our planet, right where Mexico sits now. And it coughed up so much debris into the atmosphere that it blocked out the sun. This led to devastating climate changes that caused the dinosaurs to die out. In the next wave of emerging animals, mammals became more common. Around 6 million years ago, the earliest known humans started walking this world. This species was called Sahelanthropus, though they still likely walked on all fours. 4 million years ago, early humans began to walk upright, and about 1 million years later, they developed the first known tools, which they used to break things. Some 800,000 years ago, things sparked. These early humans discovered how to control fire and could now cook food and provide themselves with heat. Their brains continued to evolve, now more rapidly than ever. These humans learned to interact with each other and the surrounding world in whole new ways. Then, between 40,000 to 15,000 years ago, all other human species besides Homo sapiens went extinct. 10,000 years ago, Earth saw its earliest farmers. These previously nomadic humans stopped wandering the planet and finally put down their roots. Jumping way forward to about 250 years ago, the Industrial Revolution took place. We went through major technological, socioeconomic, and cultural transformations. Rural-based farm societies became more industrialized urban ones. Our human population continued to grow. By 1804, we reached 1 billion. By 1927, we'd hit 2 billion. And since the 1960s, the global population has risen faster and faster to where it is now, at over 8 billion people.
In November 1884, the New York Times ran a pretty interesting story. An astronomer, known only by the name Arndt, claimed to have discovered a cubic planet, just beyond the orbit of Neptune. Less than 100 years later, another discovery was made, this time by a man who not only named the planet, but who also had maps and sketches of its alien life forms. Coincidence? Crazy? Or are cubic planets possible? Could humans live on a cubic world? How would our climate change? How would gravity be affected? Could we stand it? This is What If, and here's what would happen if the Earth was a cube. All planets are round, but have you ever wondered why? Let's go back in time, say 4.5 billion years ago. A big cloud of gas and dust called a nebula collapsed to form a hot star which, through its gravitational pull, attracted all nearby matter and formed a large rotating disk around its center. After more than just a few collisions, the matter orbiting the young sun eventually grew into massive bodies with strong gravitational centers. They formed planets. Inside any given planet, gravity pulls equally from all sides towards its center. This accounts for their spherical shape. So because the Earth we live on is a sphere, and its gravitational pull is the same wherever you go, it means that, as long as you're on a flat surface, you'll be standing straight and tall. But what do you think happens when you skew the distribution of gravity? So, you want to live life on the edge? Then pick a side. The Earth has 6 faces now, but sadly, none of them are any fun. That's because anywhere you go is going to feel like you're climbing up a steep hill. On the cubed Earth, gravity is strongest at the center of each of its faces. So the further you are away from the center, the more you'll feel its pull. Hope you didn't take standing tall for granted. The landscape along the Earth's edges would be rocky and barren, since all the water would be pooled at the center of each face, and the atmospheric quality along the Earth's edges and corners would be too thin to support life, or non-existent. We'll come back to that later. The new climate would depend on how the Earth rotates. If our cubed planet rotated on an axis through 2 of its faces, then the climate would be kind of how it is right now on Earth, only more extreme. The top and bottom faces would be polar, while the remaining 4 sides would enjoy an equatorial climate. However, if the Earth was a cube that rotated through its corners, then each side would have a temperate climate. You could say goodbye to extreme temperatures and precipitation. Sadly, that means saying goodbye to your equatorial fantasy world too. On the plus side, you might just be able to walk into outer space. Since our atmosphere is held down by gravity, and since gravity is now pulling from the center of each of Earth's faces, it means that the atmosphere would be thicker where gravity is strongest, and thinner towards the edges. What's more, if the cubic Earth had the same volume as our rounded world today, then its sharp, steep corners would actually poke out beyond our atmosphere. These areas would be unprotected and therefore uninhabitable. But who says you couldn't rent a spacesuit and stand on top of the world and outside of it at the same time? Would you do it? What else could you do on a cubic planet? Could you adapt? What would we call ourselves on this 6-sided Earth? Cubists? Cubans? We'll never find out, and that's probably for the best. But we'll keep trying things out as long as you're curious. New episodes of What If are coming soon, so be there or be square.